This lesson is lesson 3.2. In your notes packet, it would be lesson number 3. It is about the graphs of functions. So in lesson 3.1, you looked at different kinds of graphs. You graphed some different things. You talked about domains and ranges, and you wrote things in interval notation. And we are going to continue today by analyzing graphs a little bit more, especially polynomial graphs, and finding all of these things here listed in Learning Target 3D. And for this lesson, you are going to want to be sure that you have a graphing calculator. If you need to hit pause right now and grab that graphing calculator, you certainly can do that. All right. First thing we're going to do is we're going to look at a graph and we're going to identify what the function is equal to based on different values of x. So determine the following for the graph of f of x. And if we think about f of x, remember that's just another way of saying y. So we are going to find the value of the graph, what the function is equal to at different x values. So this first one over here is f of 0. So to find f of 0, we're going to go over to our graph, and we're going to do, that's the x value, 0. We're going to go over to 0, which would be right here, and we're going to go up or down to the graph. Well, that would be up here, right there. This graph has a value of 7 when x is 0, so this is equal to 7. Second one is f of 3. So I go over to the graph, I go to x equals 3. I don't have to go up or down, I'm already on the graph. So the value of the graph is 0. The y value is 0 when x equals 3. The domain of the graph. So if you recall, when you're finding the domain, you're finding the x's that make sense in the graph, the x's that exist in the graph. So the x-axis, of course, is this way. So I'm reading from left to right. And if I look, this right here is the farthest to the left that this graph goes. And this right here is the farthest to the right that this graph goes. So this graph goes from -8 up to, that would be +7. However, not every point exists. If I look here, it goes up like this, and there's an open circle here and an open circle here. So right here, when x equals 2, this graph does not exist. And then it keeps going all the way out here to 7. So to write that in interval notation, I'm going to say it goes from -8 up to 2, and it includes -8 because that's a closed circle right there. So it goes from -8 up to 2, but it doesn't include 2, so that's a parenthesis. And then it starts again at 2, but doesn't include 2, and it goes up here to 7, and that is a closed circle, so it goes to 7. And my pen is a little weird right now. It goes to 7, and it does include 7, and so that would be a bracket, and that is my answer. The range. The range is the y values. So now instead of going from left to right, the y values are along the vertical axis, so I'm going to go from bottom to top. So I look down here. This is the lowest that I go here. -9, and it goes all the way up here to +8. It includes 8 because that was a closed circle. If I go down here, it includes -9 because that was a closed circle, so it goes from -9 up to 8, and that would be my range. All right, now we're going to look at graphs, and as we look at these graphs, we're going to look at several different things. So the first thing is increasing and decreasing functions. So a function is said to be increasing/decreasing, increasing or decreasing on an interval if its graph always rises or falls as you move from left to right over the graph, over the interval. We always look from left to right. If we think about in the English language, that's how we read. So if we look from left to right here, this is always going up, so we say that this graph is increasing. As we go from left to right, this graph is always going down, so we say it's decreasing. As we go from left to right, this graph is always across. Sorry for my crazy pen here. And this is a constant. So increasing, decreasing, constant. Finding maxima, minima. So the peaks of a graph represent the local maxima, and the valleys represent the local minima. And let's just pause there and look at this graph. These would be the peaks. These are the local maxima. Maxima is just the plural for the word maximum. And this valley right here represents the local minimum. It's not the actual maximum because this arrow over here shows that the graph keeps going up, and this valley is not the actual minimum because this keeps going down. That's why we use the word local in front of them. You can find these points with the graphing calculator, which we will review here in a couple minutes. These points will determine where the function is increasing and decreasing. So to figure out where it's increasing and decreasing here, we're going to take a look at this graph, and we're going to remember that we read the graph from left to right. So if I read the graph from left to the right, I'm going to figure out where is the graph increasing. So I start down here, increasing, 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 up to that point. Then it's going down, and then right here it starts increasing again, and then it's going down, and then it starts increasing again here. So there are 3 places where this graph is increasing. Now, when I go to right where that happens, I think about how I'm reading this graph. I'm reading the graph from left to right. I'm reading it along the x-axis. So I'm going to use these x values right here and there and there and there to figure out where it's increasing. So if I start over here on the left, if I start over here on the left, it's going increasing up here from negative infinity up to negative 5. So I go negative infinity up to negative 5. And then when I think about at negative 5, it is not increasing or decreasing, so I'm going to have that be a parenthesis. Second section, from here to here. Well, that goes from negative 1 to 4. Oh, not negative 1, it's 1. From 1 to 4. The third place is right here, and that starts at 6, and that keeps going up, so that's going to go from 6 to infinity. These are the 3 places where this graph is increasing. And you're just ignoring the crazy pen, please. Okay, decreasing. Where is the graph decreasing? Let's switch to green here. It's decreasing right here and right here. So between negative 5 and 1, it is decreasing. So from negative 5 to 1. And also from here to here, which would be from 4 to 6. So also from 4 to 6, those are the places where this graph is decreasing. And that's how you find increasing and decreasing intervals on a graph. We can find these peaks and valleys on our calculator, and we'll do that here in a couple minutes. Okay, let's move on to concavity. Concavity is used to describe the way that a curve bends. For any 2 points in a given interval that lie on the curve, if the segment that connects them is above the curve, then the curve is considered to be concave up. If the segment that connects them is below the curve, then the curve is concave down. So if we look at this first picture here on the left, it is concave up. It's kind of like a right side up U, and concave down is like an upside down U. So concave up opens up, concave down opens down. And it can do those things in a graph at different places. For example, if I had a graph that went like this, sometimes it's concave up. This part over here would be concave up, and sometimes it's concave down. This part over here would be concave down. The places where it changes concavity are called inflection points. And you might want to add up here to inflection points. These are often called the points of inflection. Point of inflection. And so you might see the abbreviation POI. A point of an inflection is an inflection point. The inflection point is where the curve changes concavity. So when it goes from concave up to concave down, or vice versa. For now, we're just going to estimate where those points are. So if I look at this graph, I can tell that in this section right here, the graph is concave down. And in this section right here, the graph is concave up. This point in the middle where it changes is called that inflection point. And the way we can find that inflection point is essentially to figure out the midpoint of the local maximum and that local minimum, that peak and that valley. And if you remember how to find the midpoint, You add the x coordinates together and divide by 2. So 4 plus negative 2 is 2, divided by 2 is 1. So this point is 1, comma. And then let's do the y's. 8 plus negative 4 is 4, divided by 2 is 2. That point is 1, 2. That's an estimate. All right, where is this graph concave up? Well, concave up would be this section right here. So it is concave up from, again, we're looking at the x value, so I'm looking at this one right here. It's from 1 to infinity. And where is this graph concave down? Well, it would be over here, but again, I read a graph from left to right, so from negative infinity up to 1 is where it's concave down. All right, I'm going to have you practice this once, and then we're going to put all of these pieces together and use our graphing calculator to try this. So if you would hit pause right now, find the inflection points for this graph, and then we'll check them. Okay, so to find the inflection points, I look at where it goes from concave up to concave down. So one place that happens is going to be right here, and then over here, and then down here again. So there are 3 inflection points on this graph. To find them, I'm going to essentially find the midpoint or find the average of these 2 points. So that's going to be an estimate. So this would be, let's see, negative 5 plus 1 is negative 4, divided by 4 is negative 2. 3 plus 1 is 4, divided by 2 is 2. This is one of your inflection points. Here's a second one. 4 plus 1 is 5, divided by 2 is 5 halves, or 2.5. 3 plus 1 is 4, divided by 2 is 2. Here is my second point of inflection. And then this last one in here, let's see, 4 plus 6 is 10, divided by 2 is 5. 3 plus negative 8 is negative 5, divided by 2 is negative 5 halves, or negative 2.5. Those would be the 3 inflection points for that graph. Again, those are estimates. So now we're going to bring all of this together, and we're going to graph this function on our calculator, make a sketch. We're going to find all the maxima, minima. We're going to find where it's increasing, decreasing. We're going to estimate the coordinates of any inflection points and tell where it is concave up or concave down. So here's where you need your graphing calculator. And we're going to start by graphing that. And I'm going to pull up my graphing calculator here. And I graphed that already. If you need to pause the video right now, do that so you can enter that in and clear out any other equations you have. And then when I go to graph this function, I know that I can press graph, which is right up here in this right-hand corner. But to be honest, I don't know the last time I used my calculator. I'm not sure that I messed up the window. So I know that I can always get back to that standard window by pressing zoom 6. And that will get me back to the standard window. Okay, I can see everything in my window. I know that I can adjust my window. I could go up or down or left or right if I needed to, but I can see everything in my window. So step 1, I need to find the maximum and the local minimum. Well, the maximum is this point up here. And I don't want to just guess where it is. I want to find it accurately. So hopefully you remember how to do this on your calculator. But if not, here's a reminder. To find that maximum, I'm going to press second trace. And I'm going to go down here to number 4, which is maximum. So I'm just going to press 4. Then you get this little screen here that says left bound, and then next one's going to say right bound. So I need to move this cursor to the left. So I'm going to use my left arrow and go all the way over that hump till I get to the left of the maximum. As soon as I'm to the left of the maximum, I press enter. Then it says right bound, so I need to go to the right of the maximum. And then I'll press enter. And then where it says guess, I can just press enter one more time. And it will give me my maximum, which is right here, negative 2.8, 9.2. So I'm going to start writing my answers down here. So the maxima here is negative 2.8, 9.2. Before I sketch that graph, I'm going to find that minima as well, that minimum. So now if I go over here and I want to find this minimum, I do the same thing. I go second trace. This time I go down to number 3 instead of to number 4. Left bound, well, I'm already to the left of it, so I can just press enter. Right bound, I need to go over here till I'm to the right of it and press enter. And then I can just press enter one more time. And I get my minimum, which is, looks like 0.1 negative 3.1. So 0.1, negative 3.1. Okay, so I'm just going to try to graph that. So negative 2.8, 1, 2, 3, 4, 5, 6, 7, 8, 9.2 is somewhere up here. And remember, I'm just sketching. 0.1, negative 3.1 is somewhere down here. And I know that the graph kind of goes, oops, like that, only not really because that is terrible. Let's try this again. So it goes through like this, and then down like that, and then up, right? So that's a sketch of my graph. Okay, so I know the maxima and I know the minima. Now, where is it increasing and where is it decreasing? Well, I'm going to put these points on here. And remember that really all I need is the x value. That's really what I'm going to look at here is the x value. So that's negative 2.8. And down here at the minimum, that's 0.1, negative 3.1. But again, I really just care about that x value. All right, so where is this graph increasing? This graph is increasing right there, and then it's decreasing, and then it's increasing again. So it's increasing in two places. So the first place is from negative infinity to negative 2.8. And then remember, at negative 2.8, it is neither increasing nor decreasing, so I have a parenthesis there. And then again here from 0.1 to infinity. Where is this graph decreasing? It is decreasing right in here. So that's from negative 2.8 to 0.1. Where are the inflection points? Well, the inflection point would be right in here, right? That would be our point of inflection, only it didn't write very well, our point of inflection. And I want to find that by essentially finding that midpoint, right, that middle. So I'm going to do, to find that point, I'm going to do negative 2.8, and it's not going to write for me over here, negative 2.8 plus 0.1 and divide that by 2. And then I'm going to do the y's, 9.2 plus negative 3.1 and divide that by 2. And that's how I'm going to find that point of inflection. And when we do that, we get about negative 1.35, 3.1. That's about where the inflection point is. Okay, so now knowing that inflection point, which is negative 1.35, let me just erase that. Negative 1.35, I'll just leave it over there. 3.1, I have to look at where this graph is concave up and where it is concave down. So let's look here. Where is the graph concave up? The graph is concave up right here. This piece right here would be concave up. So that's from this x value, which is the point of inflection, which we found out over here is negative 1.35 to infinity. So that's from negative 1.35 to infinity. Sorry for the weird one. This board is not liking me today. And then where is it concave down? Well, concave down would be this part right here. So that's from negative infinity up to this point of inflection where the x value is negative 1.35. So that's from negative infinity to negative 1.35. That is maximum, minimum, increasing, decreasing, points of inflection, and concavity. In this assignment, you will have to do that, what we did here at the end. Graph on your calculator, change the window if you need to, and find all of these different things. Good luck.